Now we are going to change the mechanical system from the gas boiler of hot water heating to the CO2 refrigerant heat pump. And what we suppose we can find out is after the simulation, how it will be affected on the total energy consumption, thermal energy consumption, and greenhouse gas emission. And if we get the saving on the utility bill and carbon tax, what will be the simple payback of the system? That is what we wouldn't want to find out through this energy modeling study. So let me set up the um, mechanical system first. In order to save the time on the presentation, I have already put the system in the IES, but let's go through one by one. So this system, we're still using the gas boiler as the space conditioning heat source. The schedule 24 hours, and the heating we use the hot water loop and by two lateral draft gas boiler and no HRV and room temperature the same source. It seems the space conditioning is what we want. And how about the water heating system? And water heating system this time is the HPWH, that is a heat pump water heater CO2 refrigerant. And it rely on the water loop here. So um, this one we have the storage tank, we have the heat pump, city cold water from city go through it and do the heat exchange and to the certain degree of water temperature and distribute to um, different unit. And about the heat pump, there are two heat pump and storage tank. And one thing I would like to point out, we are not using the IES, their own auto size program. I prefer to use our own sizing method to do so. We are, you, we are currently use the Eco Sizer. It's an open source website. You can just type the EcoSizer and in the Google, it can bring you to EcoSizer website. And I mentioned before this building with 31 unit and with 31 people. And we assume in climate zone 50-degree Fahrenheit as the cold water input, and our storage tank can up to 150-degree Fahrenheit. And we use the swing tank layout that is here. Two heat pump with the storage tank, cold water flow through the storage tank and to the heat pump, and after the process and obtain the hot air, hot energy from the ambient air and do the heat exchange and transfer all the energy to the water pipe, and water will be heat up to 150 degree Fahrenheit and flow back to the storage tank, and with the stratification and different level of temperature, and we put the sensor here and do the control to determine if now the heat pump is on or off, and the hot water will flow to the swing tank and after the mixing valve and distribute to different unit. So here is what we the system work, or this is what the operation of the system. So now we move back to the IES. So we didn't use its own auto size program. We simply input the data what we find out from EcoSizer to and the minimum source of temperature and blah blah blah. So we input everything here and click OK. And so we didn't click this. If I click this, we'll use the IES auto size function. And we also consider many different elements like the water loop. We don't have any preheating. We don't have any heat recovery heating sets, and but we have a storage tank. we also consider the heat trace. So it is what we did in the baseline one. We just changed water heating from gas boiler to uh, heat pump water heater. So another approach, we are using um, the electrical baseboard as the heating conditioning source, and but we changed the gas boiler to heat pump as the water heating source. So now we check again the schedule 24 hours and the heat conditioning, uh, and the heat coil type is electrical resistant and no HRV and ERV, and also electrical resistant. So space conditioning is what we need. And about the water heating system, two heat pump, as I mentioned, we did it all from the eco sizer. So everything looks the same. So um, we'll go through the sizing and then the energy simulation. As we also want to save the time, we did it before. So let's go to Vista Pro and click the energy. So the energy will show this building, how the energy look like, and we can skip some of them because it's not the living unit, it's not our focus, and as it's not a hotel, we didn't care if there is any heating element, space heating over this area. So we put those and energy. So there's a we can select many energy. So we go to the energy breakdown and we find out different type of or different application of the energy use and how it is look like throughout the years. So it's so informed as the data from January to December throughout the whole year with different type of the energy uh, record data here. So we can simply just copy those data and we at the same time prepare an Excel spreadsheet and we just simply copy it and paste all the data here. And then, oh, it's not what we did here. Sorry. Yeah, we need to go to electrical baseboard and with the water heating system, then we place the information here and copy and paste. It will show one of the information we need. So we will going to do the energy study afterward. And when you set up your Excel spreadsheet, it will show you um, the graph, how much energy or total energy usage intensity saving and thermal energy demand intensity saving or consume more and the greenhouse gas intensity. So basically we use those methods to find out all the data and do the comparison.